Piet.
So Fernando, it's on
Yes,
you.
the next speaker will be Piet. He will speak about partitioning. After we have Bruno that will speak about Python. And at the end, Harley will speak about machine learning. So I will ask to Piet. Hi, Piet, if you can share your screen.
Yep, I can see you. You guys can see me. I'm alive and kicking and everything.
Yes, thank you so much.
This screen will stop. Yeah, continue. And I'm going to get my desktop in. It's almost like a real Zoom meeting. Can I?
Yes, we are here. We are seeing your.
I'm canceling my video, by the way, but
Okay,
you guys know I'm here and, and I'm sitting.
No problem. At the end, we will advise you the remaining time and to open Q&A if you say. It's with you right now.
Okay. Yeah, you're allowed to interrupt me from time to time, but if it gets too much, I will just say help. I am talking about partitioning, and this may look a little bit like the 1999s or something. Partitioning is fairly old, and like most of my presentations, it's based on a bit of a frustration I have with the developers or the architects who didn't or couldn't or abused the partitioning concept. About me, I ride a motorcycle. It's more or less a known item. So I would love to visit you guys, but Corona got in the way. My customer list, nah, fine. I have been wearing a mask about 10 years ago when I was in a factory in Singapore. But most of my time is spent drinking coffee. That's why the picture of the coffee cups is there. Connor told us that we shouldn't do agendas on virtual presentations, so I don't. I'll just talk about partitioning. If you want to get to your coffee quickly, my final slide will be, you better design it right. And skip to the last slides in about 55 minutes. My other top tip is always to please keep it simple. I will try to finish in time so we have a bit of time for, for question and answer and discussion. I'm actually quite curious to hear how many of you have made partitioning errors or booked a success with partitioning. So here we go. The basics. Why partitioning? It's very simple. A partition table is effectively split into many small pieces, many small tables. And that has a lot of it, that has some advantages, and some of the consequences can be can get into your way. So I'm telling you why I think it would be a good idea and why sometimes it is not. And I will try to demo that with some SQL. In my opinion, there are two main advantages. The first one is you will avoid redo. If you partition properly and use partitioning correctly, you can avoid redo in certain situations. And that's a benefit if your system is more or less redo constrained, if you have a data guard over a long line, that sort of thing. The less redo, the better. The less work, the better, always. The other advantage of partitioning is if you apply it properly and design it correctly, you will scan less data on queries. So your queries become more efficient. You don't need all the other gizmo options, and you can deliver your results to the user a bit faster. And by the way, I have to thank Tone for putting the SmartDB out there. That's a different story. This one is just about efficient queries, but I fully support, bring your code to the data. But that's for another time. There are a lot of other advantages to partitioning, like you can compress partitions. You can use reads, you can use storage tiers, go to read-only table spaces. You can use partial indexing. I think that's nifty. You can use ref partitions. I would love to try that in earnest at some point in time. You can use hybrid partition tables. I am so impressed with the capability. I would probably hesitate to use it because that is like, wow, but over-engineered. There is a lot, and if this goes well, I'll do a couple of more PowerPoints on partitioning. This presentation will be about the basics, hence back to basics. Oh, I should mention partitioning is one of the few things that's been in Oracle since about 1997. We had partition views way back. Partitioning, I think, is still a paid-for option. That means that Oracle is probably capable of making profit out of it, and it's probably adding real value to a small group of highly paying customers. That is just my sort of gut feeling about it. A lot of other options have become free over time. Partitioning is still out there. Correct me if I'm wrong, put something in the chat, we'll discuss. So here we go. I will end by telling you that doing partition properly, you can avoid redo and you can scan your data more efficient. Let's do some basics. Here's a table, and the records in that table are spread all over. If it's a terabyte table, your records can be anywhere from the start to the end of that table. You have an index, and in the index, your, for example, primary keys are nicely ordered from low to high, and this is where you can search. The index is connected to the table, and there you are. Keep this image on your mind. We will come back to this. We will explain partitioning, we will explain indexing, searching. All of it comes down to this simple mental image of a table with data and an index with pointers. I would almost go, any questions on this? But that's a bit complicated on the thing. And this would be a partition table. The table is still there, but it's split into smaller pieces. I'm using 4 in my example, but a typical partitioning would be something like 1 per day for 7 years or so. You would have like 3,000 partitions. It's not uncommon. And in this particular drawing, I have local indexes. Every partition is paired with an index that is called local. So this local part of the index only contains pointers to that one particular partition. I have that way I get smaller pieces. So all my data is now in smaller pieces. Why? Well, for example, we know exactly what is in partition 1, because that, in this case, would contain the ranges from 0 to 10,000. So I know that if a record has a primary key below 10,000, it's probably here. The optimizer can use that sort of knowledge quite cleverly. It is still one table. For the queries, the application, and all the SQL is a single table. And the indexes in this case are local. Keep that in mind. I'll show you a global index in a moment. And the big advantage is local index part is connected to local partition, local table part. Any questions? Yeah. Right. So there we go. This would be a global index. My table is still partitioned. My data is in known areas of the table, like everything between 3 and 4,000, 30 and 40,000 would be about here in this partition, but the index is no longer local. This becomes a global index. You could do that, for example, on a status field or active yes, no. All the N's would be at the start of the indexes, all the Y's would be at the alphabetical end of the index. And the pointers would point everywhere. So this global index is suddenly connected to everything. The consequences of that will be clear in a moment. So the first advantage of partitioning, remember, you just have to remember 2 things: less redo and better, more efficient query. So the less redo part, here we go. Every insert, update, and delete is work for the database. It generates undo and redo. And redo means archiving activity, means standby connectivity, means work. We don't want that. So someone says, oh, you know, on delete, truncate is really fast. Truncating a table or dropping a table is the fastest way to modify data, if you like, because it's a definition thing. It doesn't require a lot of redo. You know, I'm not going to ask any questions about this, but most people probably know that drop or truncate is the fastest way to modify or mess up your data. So yes, with partitions, you can do that. So imagine dropping a partition, meaning you delete a large part of your data with very little effort. However, you've already understand it. You probably already begin to see you can only do that if your partitioning is suitably arranged, if you know where your data is, and that happens to be the particular data you want to delete. And it actually only works on delete or on something called exchange partition. So the use case for this, if you like, is limited. Keep that in mind as well. Now, how does that work, a drop partition? Well, you type the alter table drop partition at the semicolon, hit enter, and what's going to happen is it's gone. Not difficult. And so this effectively is a very fast operation. You can delete 1 million records with a single statement, and there is virtually no wait because there is no redo generated. The definition of that partition disappears from the database. Everything still works. Nobody has to wait. So what happens if you have a global index? Now remember, this thing is connected like spaghetti. So when I type my command in there, I drop my partition. There it goes. Yeah. That part of the index is pointing nowhere. This part of the index is pointing nowhere. Is that index still useful or usable? And in earlier partitioning versions of Oracle, we know this index becomes unusable. In the latest versions, there is an automatic process that tries to quickly repair the index. But in all cases, the index is unusable for a while, and it generates a lot of effort, a lot of redo. So a lot of my advantage has disappeared. And effectively, that whole index, global index, is unusable for a short or a longer period of time. And that is something I don't want. Now, you can even run into errors that say unusable index. I forgot the exact number, but some of your queries will suddenly fail. That's not something you want to happen to the application. So demo time, I'll show you a table, a partition table, same data. We'll delete and see that generates redo. We'll delete from the partition table. That also generates redo. And then we do that magic drop partition, which is so much more efficient. There we go. And this is the exciting part, because I don't normally do demos a lot, but hey. So the demo is of course so easy. I just have to hit enter all the time. When I'm glancing at my watch, I'm fine. We create a table. We partition it by range, intervals, so that it automatically expands, which is very useful. I'll get 4 demo partitions. I'll name them explicitly. If you use interval partitioning, your partition names will be something like sys something, and that makes it more difficult to drop them because you have to find the name. No big deal. Check the table, put some data in. I have to wait for the statistics to generate. That is actually the most time-consuming part of the demo, waiting for the stats to compilate. And there we go. Yes, I have a faster script for this, but if I don't calculate the statistics correctly, I get all sorts of weird behavior. I have one table with 40,000, and I have another partition table with 4 partitions in there. Remember, we're going to delete data. So what are we doing? We delete from T, we delete from PT, and then we drop a partition and we compare that. I would be tempted to ask, are there any questions? I'm monitoring the chat, so if anything really urgent, just put it in chat and I'll read it. There we go. I'm deleting from my table about 10,000 records. That generates 23 meg of redo. And I'm explicitly querying that from my statistics because some of the operations don't have an automatic statistics here. So I'm also checking it myself and the numbers correspond. Deleting these rows, 10,000 from a table generates about 23 meg of redo from a conventional table. Let's try the partition table. Where am I? This is always, there's the conventional table. Here's the partition table. I'm dropping the partition number 2. How much redo does that generate? Well, about 34 kilobytes of redo. I'm going to do the thing again because I hit enter once too much. Please excuse me. See, this is why you shouldn't do live demos ever, because something goes wrong. Creating my index, gathering my stats. And stay away from the enter key. This is where you want to see the audience to know if they haven't been falling asleep or getting coffee or walking out. Deleting my 10,000 rows. Here I'm deleting 10,000, 23 meg of redo. Now a lot of redo. You don't want that sort of redo, but you need it. Now I'm deleting data from the partition table. I delete the similar amount of rows from the partition table. I'm getting about 26 gig of redo. A lot of work. So deleting from a conventional table, partition table, both generate this redo. Now let's drop a partition. Alter table, drop a partition. And that is only 34 kilobytes of redo. That is about 1,000 of the total. Let's have a look. If I delete my 10K records, I get about 23,000 K of redo. From a partition table, I get about 26K. You're fine, let's wave. But if I remove my one partition, I generate 36K of redo. On a sizable system, if you're dropping gigabytes or even half terabytes of data, this is a big difference. And that's where partitioning comes in as something really efficient. So main point was, if you use that drop partition, you save on the redo effort. Your log writer saves effort, your archiving is less, your standby is easier, it just saves you effort and time. Now remember, I showed you that global index, and that was a bit of a problem. So of course there is a demo that shows why a global index is a bit of a problem. Same table, same statistics, same 5 seconds wait. This is where you sip your coffee. And we're back. We have the partition table, 4 partitions, 10,000 rows each. Let's get a global index on that. So what do? We drop a partition first with a global and then with a local index. Off you go. Creating a global index on PT, global index, and ready to drop. Everyone there? Everyone still awake? Okay. Alter table, drop partition, PT1. Whoops, my index is now unusable. And someone's going to raise a finger and say, oh, but this background process will fix that in a second. Right. In this particular case, I've had that background process fix it faster than I could query. But if you drop a gigabyte, if you drop half a terabyte, you know, that background process is going to have to work no matter how. So I'm not quite convinced about those background processes. I do appreciate they're there though. How much did we do with that? We have to rebuild the index. So I'm doing that explicitly, because if I don't do it explicitly, that redo statistically goes into the background and I can't measure it. So I'm rebuilding it, and that's about 200K. It's not too bad. That's still a lot less than the total, than deleting 10,000 rows, but rebuilding an index, so as soon as it becomes sizable, you will notice this, and it will take time. You know. So now let's do it with a local index. I'm dropping the global index. I'm creating a local index. Everyone see the blue stuff on my screen, of course. I've replaced my index. Let's drop a partition. And now I am in the situation where every part of an index corresponds to just one partition. So ideally, I can just drop it with a flip. And there we go. I've altered my table. I've dropped partition number 3. You know, partition 1 was already dropped. My index partitions are, the remaining 2 index partitions are still usable because they haven't been touched. Their data hasn't been dropped. Only the data for partition 3 was dropped. And the redo size for this is in the same order as about 34K. This is the data dictionary operation effectively needs redo. And that's all. This is extremely efficient. So what have we seen? We've seen a global index. We dropped the partition, the index became unusable, and it took me 200K of redo. I've seen a local index. I've dropped the partition. The index remained usable, and it only cost me 30K of redo. Now, question for you guys out there. what would happen if those partitions were terabyte sizes instead of just a couple of K? And, you know, answers could be given in the chat, but I think most of you will understand. The other question, and this you can Google if you like, which background process does the building of the indexes, and how long would that take approximately, and what would it depend on? And again, it is something we can discuss later at the informal point. The main point was, you know, if you use partitioning, you probably want to avoid global indexes. And I will immediately give Edmund Beer, the partition product manager for Oracle, all the credit that is due. This guy is very intelligent, and we've had a couple of really good evenings discussing this. Yes, there are improvements in every version, and the improvements are really counting. I'm looking forward to Oracle 20, really. But for the moment, and basically always, if you drop a partition with a global index, you have to kick the redo. You have to process rebuild the index, and you have that redo coming at you. Back to PowerPoint. I'd be tempted to say, you know, any questions at this point in time? That was the first part of the demo. That went well. I'm still alive. My laptop didn't boot. So we've seen the drop partition. We've seen the efficiency on the redo. What was the other part again? Something about queries go faster. And faster queries mean you process less data. You have to do less work. Somehow you try to scan as little data as possible. You try to process less blocks, less IO, use less cache, become faster. Typical use case for partitions here is if you aggregate over a partition or a few partitions. And I'll show you in a moment. The anti-pattern for queries and partitioning, if you have to loop over all partitions, then suddenly it becomes a lot less efficient if you have 1 million partitions, because you end up with 1 million loops doing effort. And yes, you might be able to parallelize that, but that still means you consume a lot of resources and effort. So let me try and explain this. And this is going to be the slow part. I had my table with data all over it. I want to do something like a sum over a range. Let's say I want the sum of all number 2 records. That probably is going to be an FTS, like something like this. And maybe I don't want that if my data is really massively big. So partition table. And if we know where to look for our data, then maybe we can just scan one partition. And this is where your design comes in. You have to know your data, and you have to know and control your SQL. And then if you are lucky, and there are a surprising amount of use cases where you're lucky, if you're lucky, you just scan one partition, and it's about 1/4 of the effort, isn't it? Demo time. Let's do one of those sum queries. And demo part, there you go. Rebuilding my demo. And that's so, well, the demo rebuild. So I'm going to query on a sum, and we will see where a partition makes the difference. I'm just rebuilding my data. I'm glancing at the other laptop all the time to see if there are any worries. No worries, we're good. I tried to do this with a single %, and then it upsets the cost-based optimizer. There is one big lesson of all the demos: always get your statistics, because the cost-based optimizer will try to outsmart you and do something stupid. So you have to wait for those statistics. Here's my partition table, 4 partitions. Let's go on the demo. This is the sum demo. So what do? We aggregate the data first on a table, then on a partition table. And normally we would see that doing just a single partition. Let's have a look. I got my select sum something. I'm doing a table access full on my conventional table, group by, etc. There we go. See, I was lucky. The cost-based optimizer agreed with me and did a full scan. The statistics, here they come. This particular query, if you list it, if you execute it again, you can see that it scans 5738 blocks, so 5,700 blocks. Now let's try doing this on a partition table. Remember the 5700? Oh, here you go. So we do the same query, this time on the PT, the partition table. Here we go, table X is full. You think, oh, that's not good, is it? Partition range single. It's only done that full scan on a single partition, partition number 2. That makes sense if I look at my between condition here. So yeah, this probably did exactly what I wanted. This did what I designed it for, so to speak. There you go. And how much effort do you think it would be? Any volunteers to type in a number? Coming. There we go. Same query, this time with statistics. 1475, and that's about 25% of what it was on the full table. So yeah, in this particular case, this demo is of course totally rigged to work. And there you are. This query would become about a four times more efficient. It scanned a quart of the original blocks. And again, on large objects, on a lot of data, this is going to count. And the main point is made. If you can do partition elimination, your queries become a lot more efficient. You literally have to search through less data. And again, on large volumes, this counts. This is, of course, a laptop, so who am I? Let me reset my demo. Well, so that was the demo of the sum. Any questions? Put them in chat. There is more about queries, another slow part. If you look for the primary key, that's easy. You will have an index, and that's mostly a local index, and that'll work. If you look for something where the range is active as yes, you may have to scan a lot of data. You probably want an index on active, yes, no, but would you choose a global index or would you choose a local index? And here's the point again. If you end up looping over all the partitions, you're probably doing it less efficient. Here's the illustration. Conventional table, records all over the table, index on the primary key. You're looking for ID is 2, that would be a primary key lookup. In a conventional system, you would go to the index leaf, you would point to the table and pick up your records with about 4 IOs. On a range scan, if you're looking for all the active records in a conventional table with a conventional index, you would have a range scan, of course. You would have all the N's and a couple of yes. You would go to the yes area in the index. You would then jump to the table and pick up your data in about 1, 2, 3, 4, 5, 6, 7 gets. Probably you probably need 7 blocks to do this. Partition table, looking for a primary key value somewhere. That's easy because I know if the primary key is 1, it'll be in this partition. So I can go that partition, pick it up, 4 blocks probably. The cost-based optimizer, Oracle, knows that this particular ID value will be in that partition. That's a big advantage. Now, if I look for all the active records, it's a different situation, and I probably need a global index. There you go. Scan for active is yes. Go into the index, find the index block, and do 4 jumps to 4 different partitions. That's fine. And this is efficient. This is what we would like. The problem is this is a global index. So what happens if I make that index local? Let's have a look. This would be the local index. Each index will have the N's and the Y's for its partition only. So I have 4 sets of indexed values. If I'm looking for active is yes, I'll start with the first index partition and I'll find some. But I'm not finished yet because I need to look at the next index partition, see if there's any Y's in there. 1 more index partition, any Y's in there? And actually I need to look at all the index partitions to see if there are any Y's in there. It can be a bit more intelligent if the cost-based optimizer knows that it only ends in a certain partition, then that's fine. But the problem you're facing is in a lot of cases, you would have to do this for say 7 years of archiving, 365 partitions. That ends up being like 1,500 partitions, and it's a lot of looping. This becomes expensive all of a sudden. You're looking at milliseconds or whole seconds just to scan through that data. And that's what you don't want. This is where your design sort of failed because this query would become very slow. Demo time. let's do it. I'm going to find all the records with status is active, yes, and I will compare global and local index. Let's have a look. Okay. So I prepared my demo again, switching to SQL+, prepared my demo. And could somebody put an encouraging word like I can follow this in the chat, or say something like slow down? Okay. Demo, looking up a range of values. There you go. So I'm going to use a local and a global index, and I'm going to find a small set of values. First, I got an index called global index on the field called active. Here's my index, my stats. The global index is there. Let's use it in a select. I get just scrolled off the screen. So I've got a select where active is yes. There are 4 records with a yes value, and I sneakily placed 1 in every partition, of course. And I need to, there you go. So what's happening, I'm doing an index range scan on that global index, and we found the 4 records. The cost of that thing is about 2. Let's have a look at the stats. We do the same index, the same query once more. There you go. Same 4 records come back, and guess what? It did 7 block gets, like we predicted. 3 in the index and 4 jumps in the table. You know, cost-based optimizer is predictable. So it walked the index B level. It jumped at the 4 records. I got 7 IOs, and I remember I got 4 partitions. Let's try a local index. Drop my global index, create a local index, get my stats on it. Ready, same query. Select where active is yes, and same 4 records come back. This time I have an index range scan on my local index, and I'm accessing by row ID, and I'm doing that in every partition. Can anybody guess how many IOs this would generate? Answers in the chat, but I'm in a hurry. Let's run it again, have the stats in there, 12. So my guess is the B level of this in these local indexes a bit lower. It did 3 jumps in every, it did 2 jumps in every index and 4 jumps to the table. And if you start doing this with like 1,500 partitions or like 1,000,000 partitions, like Gaucho did at CERN, you end up doing a lot more gets just to get your records out of there. And this is where a local index can be less efficient than a global index. The main point was local indexes can lead you to a lot of looping. And in this particular case, the global index was more efficient. But if you don't want global indexes, you will always have to limit yourself to 1 or few partitions. And this is the design problem for partitioning. You have to find your partition key so that it's always in the query. We'll come to that. That was the demo for this one. Now, the title is Pitfalls. So what are the pitfalls in my opinion? 1, you have to avoid those global indexes because they cause you extra work when you drop or exchange or truncate a partition. And you have to avoid that partition range all. You have to avoid the looping. It's as simple as that. The consequences of that are you need to build your design proper. The consequence is that just every query in that system needs to have a partition key. It needs to know which partition to go or which limited set of partitions to go to. If you have partitioning by day and you keep 7 years of archiving, you end up with 1,500 partitions. You know, just please, when you query for something, add a condition that says, I only want to look at the partitions for the last month. And then you have to loop through 31 days, which is fine. But if you have to loop through 1,500 partitions, you're probably in trouble. So design, you know, if you want to take anything home from this particular presentation, remember you need to design this. We're doing well. I would now ask the audience some trivial question to see if they were still awake, or do we need more coffee and stuff like that. But I have a bonus trick, of course. When they told me it was 60 minutes, bonus trick. So I'm not saying that what I show you now is a good idea. but that always wakes people up. Now, partitions are mostly a date thing. Most of the partitions have a date component, are on time, are on the range, are on order, something like that. There is another notable exception if you use list partitioning on customer IDs or customer names or states in the United States, which is a classic almost. And I haven't actually seen any good examples of list partitioning, but I'm convinced it can be used. I think everything I've seen in partitioning was always on date. And I'll tell you a secret. I think I've seen less than 15, maybe 10 systems with partitioning. I think 2 of those were a good success. The others were marginal. And most of those failed partition systems are saved by the fact that hardware is so blightingly fast that nobody notices a clumsy design anyway. Anyway, so I would say no global indexing. That causes a problem because you can only have one unique key and it has to be the partition key. There's no way you can enforce uniqueness on a local index because the local index can't see the contents of the other partitioning. So I'd say if you use partitioning, please start on a greenfield design. You cannot bolt partitioning on an existing system. I've seen it try by an American vendor, not Oracle, on a factory system in Asia. And it was just the mess became even bigger. You know, they couldn't fix the problem. They just made it worse, but don't get me started on that. Now, the bonus trick is you need a primary key. And ideally you put, and this is bad practice, but you could put information in that primary key. You could say, I'm picking my date, which is the Y, the D, and the S, and I'm adding a sequence of about 1 million, and I'm cycling that. And then my primary, I could choose epoch, I could choose, I can try naming the epoch date, which is ends up with 10 digits plus 6 for the number behind it. Or I could try year, day number, and number of seconds in the day. I end up with 18 digits. Or I could do something really readable, and I could use the year, the month, and the day, the 24 hour, the minutes, and the second, and then add my 6 digits to that. And I end up with a 20-digit field. And that would function as my primary key. You can also check Frank Pachot's blog on GUIDs and primary keys, and his conclusion is actually don't use GUIDs because GUIDs are not really usable. You can't range them. They contain no additional value over an integer technical key. But if you sneak, totally bad practice. I'm expecting something from Tone, by the way. If you sneak a date into your primary key somehow, you can fairly easily search on date ranges. And if you reserve about 6 digits behind that, you can do about 1 million records per second. And the integer is still small and efficient. We need to discuss this after the session because I'm expecting a lot of burn on this. And you guys are right. And maybe you shouldn't do this. However, I know of a few systems where this would have saved a lot of hassle. Here's a demo. This is my hobby. You know, the whole presentation is just to do this particular script. Okay. So what we want to do is we want to use a date plus a sequence as the primary key, as the technical key of a field. Normally, you would just use a sequence. I've just sneakily inserted a date into that. Let's try. I've got my sequence. I'm starting at a very high number so that it looks good. And I'm cycling it at the 99. I'm cycling it just before the million. So this never goes over 6 digits. And when I reach my 6-digit limit, I'm starting at 1 again. I got a table where this thing becomes the primary key. And that number has to be big because it has to contain a really large integer number. Let's have a look. If I select that properly, this would be my date part. This would be my sequence going 4, 5, 6, 7, 8, 9, and cycling back to 1. And I'm inserting leading zeros here. So my ID, my technical field in my table, my key field, would become this. And it would cycle here. The first problem someone should mention is, what if you want to insert 1 million records in a single second? The answer is you can't, and you would have to reserve an additional digit or two. But how often would that happen? And it probably happens in your particular system, but we can cater for that. We'll just add 2 more digits. So now I'm putting that in a table, and then when I select from the table, I can see that my IDs are here, like numbers like this, and the byte size of that is only 10. So this looks like an impressive number, but it only takes up 10 bytes of storage. A GUID would take 16, for example. And this is how you can sort of work around the fact that a partition can only handle 1 single unique field. Partition table, no global indexes. That means you can have 1 unique field, and it has to be the partition key. And in my case, I would recommend you try something like this. Be very careful. This will only work in specific circumstances. So that is the end of my hobby. Any questions on that? Okay. Looking at the chat, nobody even bothers to chat anymore. We're good. Please tell me afterwards if this was interesting or not. There we go. So I come to the end of my presentation, and don't worry, there's a couple of slides left. My summary, going back to the start, is of course, you guys probably remember, you have to design it. You can generate less redo, but you shouldn't have global indexes. And I know they're working on that. That there will be developments in the later Oracle versions. And if you really want fast queries, you need to put the partition key in every where clause in all your application code. Now, you already knew this. This is why there is a watch there. This is not my timekeeping watch. This watch means I'm asking for your watch to tell you the time, typical consultant. There are a number of surprising lot of useful cases for partitioning. Partitioning is not limited to the cloud, and partitioning, by the way, doesn't benefit from blockchain, but never mind. But the typical use case would be something like a time series. If you have a lot of data and it's time related, and that could be as simple as all the transactions of a day or transactions coming in sequentially. So time series or any time related data is a candidate for partitioning, and a lot of people probably already told you that. There is another nice case if you have fast moving data, notably with large inserts and deletions. If you need to insert a gigabyte every hour and delete a gigabyte at the end every hour, you can save half the redo because the delete could be a drop partition. This is typical for batch operations with messages coming in. Messages are kept for about 3 months and are deleted at the end of the 3 months. The delete process is where you save when you drop your partitioning. And there is another case, and I haven't demoed it or haven't actually used it in anger, but if you use list partitioning, you are effectively sharding your data. Think about that. If Oracle tried to sell, any Oracle people on the call? If Oracle tried to sell you sharding, sharding is nothing else than list partitioning of a group of tables. Think about that. You can save money if you decide not to go for sharding, but use list partitioning. Basically, if you want to use partitioning, be my guest, get the Oracle license, etc. But it will only work successfully if you have a lot of hardware, which is fine. So you can hide your errors in the hardware, but it will work best if you know your data, you know your data model, you control your database application, you control your code. You basically have to have your partition key in every query. Cannot say that often enough. Now this, I expect some questions on, because I know most of the partition systems out there have a global primary key or don't have a primary key effectively, and generally have a lot of indexes that are not quite, that are either not local or kind of clumsy. I've seen more disasters in partitioning than actual successes, and that's the reason why I did this presentation in somewhere late 2009 already or so. I fully appreciate the whole PowerPoint looks like previous decade, but that's what it is. if you do partitioning, design, 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 and then, you know, you get my thumbs up. There are some interesting times ahead because there are improvements coming all the time. And I am particularly keen to try some of this, notably ref partitions. I would love to sort of load half a data model with a parent and 7 child tables, and then just drop the whole thing in one go. Partial indexing looks very useful to me. Hybrid partition tables. Yes, I know Roger McNichol is quite enthusiastic about it. I think it's a great feature, but I'm a bit careful. Now, whenever I am careful about a feature in Oracle, it becomes the main selling point in about 2 years from now. So hybrid partition tables probably have a great future, but to me, it's sort of kind of counterintuitive to join data in and out of the database in single queries and stuff. So be careful with that. We should discuss, you know, any of you have questions, remarks? I'm really curious to what's out there in the wild. And if we have a good discussion, I'll do another PowerPoint in maybe not next month, but somewhere later about partitioning again. There's a lot that I think can still be said. There is a lot that I think, especially new features that we should explore that I'd love to test, but I need a good excuse to do that. You know, never take my word for anything. Read the manual, test it for yourself. Make a note of this guy. Edmund Beer is the Oracle product manager for partitioning. His Twitter handle is Sierra Delta July Hotel 2000. And he does reply to questions quite well, actually. My last word is always, you know, can you please explain it simple? Can you make it simple and explain it to the next colleague out there who might be speaking a totally different language? And, you know, Goethe, the German poet, always said, the limitation shows the master. If you Google that, like Bryn did, I think, and he said, Piet, you need to change your tagline. That limitation shows the master is old. So, you know, yeah, but it's valid. Q&A. Basically, you can now shoot holes in me. Over to you guys.
Yes, thank you, Piet. It was amazing. Well, we have some few questions. The first one is if you can, if I understood correctly, if you can speak how the partitioning pruning can help or something like that, or how these work apparently.
How partition pruning works. Yes, I probably have a good slide for that. Partition pruning is best illustrated on here. Oh, are you all still seeing my screen?
No, not yet. Just
yeah. Let me go back to Zoom. Go back to Zoom. Share my screen and screen and screen. Go back to PowerPoint and find my PowerPoint. Share. Yeah, and here. You guys are seeing my PowerPoint now, right?
yes.
Yeah, this slide. This slide shows partition pruning. What you have is a table with, in this case, 4 partitions and local indexes. If you know, if you're looking for ID equals 1, so this one, you know that ID 1 is in the first partition. You go to the first partition, you look up ID 1. The cost-based optimizer already knows that he doesn't have to look at the other partitions because ID 1 is the partition key and all the partition keys between 0 and 1000 are in that particular first partition. This is pruning. And if you don't have pruning, you end up with the next one. So this one. If you look for a field that is not part of the partition key, if you just say where active is yes in a query, you need to visit every partition to see if there is a yes in there. So this is not pruned. It has to go through all the partitions. And if you have a 7-year archive, you probably end up with 1,500 partitions. This is not pruned. If you know that your active is always in the last month, so say sysdate minus 30 or sysdate minus 90, which is quite common actually, you can say where active is yes and sysdate bigger than sysdate date bigger than sysdate minus 90, and then you know you only have to search 90 partitions out of 1,500. And then you've done partition pruning. The pruning means you've removed partitions from your query. You've removed partitions from your search set. That's what the pruning is. I hope I have explained it like this. If not, we'll do a one-on-one somewhere, but raise your hand if you understood this, or put the thumb down if you haven't understood it yet. And I'm fully aware that if when I was new to this, my first partition course was in 1998 or so, and I was wondering, what's this about? Yeah. It took me a while to get the hang of it.
I think that was clear, but yes, more questions.
Question guy, you know.
Yeah, we have 2 questions.
Yep, go ahead.
That one is from Bruno that asked, he told that usually when the years change from 2019, 2020, depends on how the guys define the partition, have errors or need to check again the partitioning.
Yep.
So how
That makes
you can avoid this and tell to the developers to do or to change the way the partitioning?
I think this comes down to when you query a partitioned table, you need several things. But one, you need to make sure that the indexes you will use are usable. And if you've removed partitions or dropped partitions or exchanged partition data, you can have unusable indexes for a short or maybe longer period of time. That will give you an error, and you need to wait for that process to catch up, or you need to rebuild those indexes. That's one possible error. Another error can be if you are at the year change and you are trying to insert data in on a partition range where there is no partition yet. And this means someone has to manually add partitions. That used to be a problem in Oracle 8 and 9, I think 10. As of Oracle 11, we have interval partition. You can define your table in such a way that it creates its own partitions, and you're relatively safe at that. Is that more or less? Let me read the question. SAP, the database, every change of year batch used to face errors. Yeah, what could be done? Okay, to give a better example, that's Bruno. Hi, Bruno. My view is over there. Send me a mail. If you have the exact error, I can probably give you a better answer. There's an Aura dash 111555 or so, you know, rollback segment, but yeah.
I think that, thank you. I think that we have 2 questions that are related. One is there is some kind of advisor that shows if the table is good or no to be partitioned, and including with this question, do you agree that just tables that have more than 2 gigabytes are good to be partitioned or no?
That's a tricky one. I know a number of architects who will say anything above 1 or 2 or 10 gigabyte needs partitioning because of recovery and block errors and things like that. That is probably ancient knowledge. And I'm not going to give you a size. I'm not going to say that everything above a terabyte needs to be partitioned, because I've seen tables of multiple terabytes and they work, and I would probably never partition them. if an advisor, yes, I know Oracle has tried it. I know there's a Lillian Dobbs tried this in the early 2000s. He had a whole lot of scripts and questions that you could answer to see if your data was fit for partitioning. But that was mainly a sales activity by Oracle trying to sell the partitioning option. I would say common sense is the first thing. Another one is if your table is seriously big and growing over time, you probably, you can consider partitioning. But you end up in trouble if you need unique constraints on the table and they're not part of the partition key. So I hesitate a bit. The only really good partitioning is right from the start of the design. And ideally, you know whether it's on a customer list or on a time variable somewhere. Does that answer the question more or less?
Yep. And just to return. And yes, is there the...
I think we're running out of time, but oh no, we're
yes,
fine.
we have 5 minutes.
Yeah. Yeah.
So I think that
my alarm just went off and I set that for 5 minutes. So, yeah. Yeah, go ahead.
So I think that is that. We are fine.
I see the execution plan. Do we know? The quick answer to that is no, you probably need to look at the execution plan.
I have one question.
Yeah,
that is I remember something that I made in the past. What do you think about that we partitioning with, how can I say that? Just to cut some details, but to partitioning using the security files and something like that, because internally we can define some parameters in security file. What do you think about that?
Yes, because especially, well, mainly if you need to delete or archive the secure files, effectively you're partitioning a table with blobs, and the blobs are in a separate segment anyway. So the careful answer is yes, probably, but only if your parent data has a proper partitioning somewhere.
Yes, the point is that we partitioning and we do the partitioning and still put the blob separated, or just put the blob is good enough?
You mean the blob? I would always put a blob not inline, but in a separate segment. And I wouldn't probably not hesitate to define one or more blob columns on a table if it needs it. I'm sort of against creating a separate table for documents or blobs, but there can be good reasons for that, by the way. And then that table becomes really big, but the size is not in the records part of the table. The size is the blob, the secure file. And only if you want to delete or exchange parts of that table will it help you to partition, I think. Yep. So my careful answer would be maybe not. And if you do partition, make sure you have a good reason for that. So I know that's not a good answer, but that's it. Yeah. Does it help, or did I miss it?
Rodrigo, have another one. Yep. Do you like the subpartition data?
Say that again. Do I like?
Subpartition data.
Oh, yes, I was expecting that one. The careful answer is no, because it creates an additional layer of complexity for me and others. So having said that, the first answer would be no, and I would ask why. And if the answer is I want to partition because I have proven contention on things like indexes or inserts or blocks, if you have proven contention, if you have many processes accessing the same small amount of data, then partitioning can help. There is an old trick. If you list partition stuff and list partition it so that every record gets in its own block, you don't get block contention. But that's an Oracle 9 trick. So subpartition, my first answer would be no. I know that's a bit stupid. So a lot of subpartitioning fixes problems that used to exist in Oracle 9 and 10, block contention. Not so much anymore, but there are probably people out there who can counter my opinion.
Another one, I think that we need to finish now because to the next one, but the last question is, which data type perform well during the partitioning process? Delete, truncate, which one is better? Hash, interval, time, which one performs better?
Okay, I'm not sure if the data type makes a big difference in partitioning. Searching on integers, on indexes, searching on numbers is always faster. So numbers, and a date in Oracle is a number. So numbers and dates are probably the most efficient things to partition by. And then I'm speaking of range and list partitioning. If you use hash partitioning, and I deliberately didn't mention hash partitioning in the presentation at all, hash partitioning will solve a problem that doesn't seem to exist much anymore. Hash partitioning is to solve contention and possibly to help parallel processing. So I'm a bit careful on this. I would almost say I'm not quite qualified to answer this question. Sorry about that.
No problem. So I think that thank you, Piet. Now we will open to then Bruno to continue with the next presentation. That is DBA Python for DBAs.